Hello everyone and welcome back. It's Twiss and I'm very happy to have you back around here for, I think it's the 5th part of our game development streams, and today we want to basically add some player physics so we can actually walk through the world as a player. So that means that we have some gravity that pulls us to the ground. We should be able to move around just as we do now. And then, of course, basically add collision detection with the terrain itself. Before we do anything though, let's start up the game so we can see what we did in the last stream. Basically, we added a way of procedurally generating our world depending on a fractal noise concept. And as soon as that's loaded, you should be able to see it. There we go. And we also added loading and unloading of chunks around us in a radius that we'll be able to set. So that's great. Of course, the world's still quite ugly as our grass texture isn't the best looking, but we're gonna change that out in the future. And as soon as we add stuff like trees and so on, it's gonna be a whole lot more interesting to, walk through this world, I guess. So let's get started. First of all, as I said, we want to basically implement a player. And therefore, of course, we'll start by adding the player header. And in there, of course, we do the pragma once. And then we are gonna need GLM. So let's also include that. GLM/GLM. Perfect. And then let's start with our player class. That's a little too much for now, I would say. Let's just put a closing bracket there, as well as the semicolon so we don't forget it. And then let's start with our public attributes. So first of all, of course, we're gonna have that player constructor. But that's just gonna be this for now, and then we'll have, basically the GLM position, so a vec3. So we always know where our player is at. Then we want a direction. Perfect. And then we want some stuff like a radius for our player. So we have some thickness. Let's go with 0.3 for now. Kind of thin here. Then we want a height for our player, of course. Let's just say 180. Then we want to know whether we're on the ground. And we want to have a move speed. And yeah, let's just set that to 5 for now. Then let's actually pass something to the player. As we have a position, we're gonna need a starting position. So let's just do GLM vec3. And of course, we can just call that start position. Yeah, let's just go with start pos. That's gonna be enough. And then we're gonna need some methods. First of all, we want to update the player from time to time. So let's pass delta time. Probably we are also gonna need a reference to our world. So let's just do that. And then we not only want to update the player, we also want to be able to jump around. So let's also declare that. And then we want to be able to move around. And for the movement, we also will need the movement direction, of course. As well as the delta time. And then, well, probably also in here, we're gonna need the constant world. Okay, so with that out of the way, well, we also need to probably forward declare the world here. Yeah, then that's also fine down here, perfect. Then let's add the player CPP. And basically what we can already do now is add those two in here, or basically only the player CPP, because we already have the other one in the include folder, the header. Well, that's not true, right? Do we include the source folder? Nope. So maybe we should... No, we don't need to include the H file if we include the CPP, correct? Okay, let's go ahead and call that player.cpp, so that also gets built or included in our build. So let's go back to player.cpp, and then of course we need to include our header file. And we also want our world. Then let's quickly do our constructor. That should be fine with the start position, and well, the direction, we don't need the direction, right? Let's just say we want to initialize the velocity. Did we call it velocity in here? No, we called it speed, right? No, that's not the right thing. We don't have the velocity in here, right? We should have though. Why did I call that direction? Let's call that velocity instead. And then in here we can say velocity. And well, let's just pass 0 in there. Okay, then we can start with the easy stuff, I guess. So basically maybe player jump. And basically that wasn't too bad already. We want to check whether we are on the ground. If we're on the ground, then we can set our velocity.y to be equal, yeah, let's just go with that 5 for now, I guess. We can always change that later, and then on ground is gonna be false. Okay, and I think we need to then probably do the update next. That would make sense at least. Void player update. And we said that we want to have the delta time there as well as a reference to our world. Then let's go through this one by one, not do it all together. So first of all, we want to check whether we are not on the ground. If not on ground, then the velocity y is gonna be minus our gravity basically times the delta time. So if we're not on the ground, we get pulled down to the ground. Okay, then we want to do the basically collision stuff next up, I think. So we're gonna need a next position. Let's not call it new position, but next position. So vec3 next position. And that's gonna be position plus the glm back 3. And let's say this is gonna be 0. And the z-axis is also gonna be 0 for now. And the velocity y, we can just multiply in here with the delta time. Doesn't change anything though. Okay, then next up we want to calculate our ground height, but we don't want to do that with our Perlin noise. Otherwise we would need to, if we ever changed our Perlin noise world creation, then we would also need to change it here. Of course, we don't want to do that. Instead, we're gonna add a helper function, world.getHeight at, let's leave that position away. And let's just say position.x and position.z. Okay, then we really need to check the collisions. So if our next position dot y minus our player height times 0.5 is below our ground height, why is that here? Then we want to set our position.y to be equal to, is that correct? Ground height plus height times 0.5, yeah. And we want our velocity.y to be 0 again. And then we're on the ground. So basically we can set that to true again. And if that's not the case, then we want our position.y to be our next position.y and our on ground to be false. That's already the update function. Of course, we called it position here. So it should be also called that way. Perfect. And then basically what we want to do next is just the player movement. So we're going to implement the movement function, player move. And I think we said we want to do the move direction, delta time, and the world. Let's get rid of all of that for now though, so we can actually go through it one by one again. So basically what we need is our position, so vec3, or basically what we actually need is our old position. So let's call that old pos equals position. Yeah, perfect. And then we want our glm. We could also call it next position here, but let's say it's the intended position, because basically we want to check whether we collide with anything, and if we collide with anything, that's not going to be our next position. So basically that makes kind of sense, I would say. And in the intended position, of course, we want to do our old position plus our move direction, and that's going to be multiplied with the move speed and, well, our delta time, I guess. But of course we need to remove the y component of our move direction here, because we handle that later on. So basically what we can do here is just remove that, add a new glm vec3, and in there we're gonna just call move direction dot x 0 and move direction dot z, and then we multiply that with the move speed and the delta time. Then we're gonna try our movement. So if world dot we'll create that function later on. If position is free, basically, then we're gonna give the intended position, our radius and our height. And if that's true, of course, we want to say our position dot x is going to be our intended position dot x, and our z position is the intended position z. Perfect. Then, if that's all fine, then we can just return. And if that's not fine, let's just do it here. Then we'll only try the x position. So if we collide only on one, well, axis, we want to, well, basically travel in the other axis if we're moving diagonal. And most of the time in a 3D world, you're moving diagonal and not only on one axis. Because of course we're gonna be moving not on like the block axis, but in the direction where we're looking at, except the y axis. That's only gonna be accessed by jumping. So let's say we have our x position equals to glm, the intended position dot x, the old position dot y, the old position dot z. And then if our world dot is position free, x pos radius height position dot x equals x position dot height dot x. So that's only if we do the x position. Let's get rid of that return statement, because we also want to check once again whether we're able to move in the z position. That's the same stuff. We do the old position dot x, old position dot y, and our intended position dot z. So if our world is position free, z position, radius, and height, then of course we want to set our position dot z to be our z position, which we just calculated. So basically what we now only need to do, I think, is, of course, we're gonna need to instantiate a player and so on, but for now, let's add the getHeight add and the isPositionFree function in our world. In order to do that, let's first of all go to world header. In there, we can simply add our function declarations up here. Let's say we have a float for our getHeight add function. There we're passing an x and a z value. And then in here, well, we don't want to define that. Of course, we want to define that in our CPP, in our source file. Then what we're also gonna need is a bool for our isPositionFree, and that's probably fine. We want our position, our radius, and our height. So that should be perfectly fine. And then we also want another bool, isSolidAdd. We didn't talk about that yet, but we're gonna need that later on. So we can check whether we can land there, basically. Okay, so we got that set up, and then we can go to our source file here and add those functions in. So let's say we wanted to start with our float world getHeight add. And as we said, we wanted to pass an x and a z value, and that should be constant. And then we want to basically start our block here, and that should be fine then. First of all, we of course need to find the right chunk and then find the right cell in the chunk. So let's do int chunk x, should be a static cast int, of course, from x, and then, well, the same for z, divided by the chunk size. The way it tries to access chunk size doesn't work here. Why is that though? Don't we have chunk in here? We have chunk in here, but that's not the way to access that basically, I would say. We would need a reference to our chunk. Wait a second, no. Basically we want to divide it by our chunk size, yes. How can we access our chunk size from world? If we don't have a reference to our chunk, we only have chunks, but then, well, if we have chunks, we can always say, where was that? Down here. Let's just say chunks 0, 0, and then chunk size. And then let's do the same thing here, basically. Do I need dot notation or is it gonna be fine? Let's check that again. Nope, I don't want to change all of that. I think maybe we need to change it in a second, but well, that's not gonna be a big deal. If we have that chunk size, it's gonna be no big deal to get the X then. So basically what we want to do is use the modulo operator here so we can get the rest of our division. And basically that's gonna return our local X. Then we can just go ahead and duplicate that for our Z. And then of course we need to put the Z in there as well. With that out of the way, we basically can get our chunk. And then we can say if we don't have a chunk, then, well, basically we want to return 0. If we have that chunk, then of course we want to get our cell. And if we don't have that cell, then we want to return 0. What's the matter here? Well, somehow still the same issue as here, right? But I think we're gonna need a... We got the chunk H in here, so it should be fine. Let's just not worry about that and move on. If that cell exists, of course, we want to return the cell height instead. So that should already be it. We're gonna see whether that's gonna work. Next up, we want to do the bool world is position free. Well, like that. And we said that we wanted to pass what in here is position free is going to be like this. And then let's not forget the constant here. Okay, then of course we need to loop through basically our y. So let's do float y equals 0, y less than height, and then y plus a half. And then if we did that, we can basically loop through an angle. So let's loop through angle. Of course, we don't have mpi yet. We need to include math, I think it is, right? Yeah, cmath it is. So let's do that. Include CMath, perfect. Then mpi shouldn't be an issue anymore. And then of course we want to angle plus equals mpi. And well, let's just go with division by 4 for now. And then we have our, well, that's not what I wanted here. Remove that. So basically we want to once again check x, and that's gonna be our position dot x plus our radius times the cosinus of our angle. And then we want to check our z position for the same. And last but not least, we want to check our y position, and that's just gonna be, well, our position minus our height times half plus y. That's great. And then we want to check whether the cell is solid at that point or not. Yeah, it's a little confusing that we basically check if it's solid and then return false here, but I think you will get it. So let's implement that is solid thing. Like that. That's a little too much though. So let's just start by doing our in chunk x again. Yeah, that sounds great. And our local x and local z as well. Then we can get a chunk there. If we don't have it, we're going to return. If we find the cell at that location, then we can check whether we have that cell. If we don't find a cell, we can actually get the cell height. We don't need to get the cell height. We're just going to check the cell, return cell is solid at, and then we're just going to pass the y. And of course, we didn't implement that function yet, but that's not going to be, well, too much of an issue. So basically what we want to do is go to cell.h and add a function bool is solid. And then I think I want to define it in here. Wow, solid. We want to add a float y. And that can be constant, I guess. But then we're just going to do it this way. And well, we're going to define the function in here. So let's say bool cell is solid. Is that correct here? Well, basically, nope, not the way I wanted it to be, at least. Probably we could do it this way, but let's say we want to have our cell top, and that's going to be our height. And then we want to have our cell base, and that's going to be cell top minus the cell size. And then we want to check whether our y is bigger, nope, bigger than cell base, and y is less than cell top. So we basically put the player in the middle of the cell. Outside of the no, we check whether the player is in the middle of the cell. Of course, we need to put a capital B here. And if that's the case, then we just want to return. Don't need that here now. If that's the case, we want to return terrain types not empty. And our terrain types back is unequal to terrain type air. I don't think that's going to work out as we intended it, but we're going to check on that later on though. So that should in theory at least work. Let's go back to player source file and world source file. They should be now fine, right? Don't we have the cell on here? Or was it? What is causing the problems? No, we got the cell in here. Is that the dot notation that we need? No. So it should in theory work. Let's just check. Probably this though is not the way it should. This is definitely a member function as far as I remember. Let's just start debugging. And if we, hello extreme. And if we have any issues, then we're just gonna ask our friend, or well, we can basically check first. So, wow, that's a lot of error code. Yeah, then let's try that again, but you mark that for me. Okay, once again, some errors. Okay, so quite a lot of errors still. Okay, the chunk size is private, but I think we have the get chunk size function, right? Can't we just do get chunk size? Totally forgot about that. Got a getter function for that. This definitely shouldn't be private. Let's check chunk though. Get chunk size is definitely not private. So maybe that's just old. Let's just run that again and see whether that's now not causing any issues anymore. Okay, so the next one is right in here. Chunk cells is private within this context. Probably we did the same thing there. Our cells are private. Yes, but of course we can just get a get cell method. So let's say we have nope, I want a get cells method, so we need to do it in a vector format, and then we're just going to return that. Okay, so that should be fine right here. And then mpi should also be fine as we included cmath, right? So let's just check again. What's the best way to learn C++? Well, a couple of years ago, I would have suggested, well, watching either some videos or basically using a written down tutorial, which works better for me. But nowadays, I would say, well, start with a few tutorials or a book. if you're into books and that kind of stuff, but of course it's much easier if you just get started, and if you don't know about something that you want to do, then just open up your chat in, well, Visual Studio, and he's gonna explain everything that you don't know. So that's a great way to learn coding these days. On the other hand, well, it's often said that it's not the best trade to learn these days because it's going to be done by AI in the future. But I don't care. I just like programming, and, well, till now C++ has been quite fun, and also the combination with OpenGL has been quite fun. So where do we do that? In World CPP 141. Let's go there then. Let's do, well, that's the get cell function that we then need. So let's do chunk h, and let's do cell get cell, and then if our local x is less than 0 or our z is less than 0, of course we want to return nothing. And if our x is bigger or equal to chunk size, or our z is bigger or equal to chunk size, which should be 16, then we also want to return a null pointer because we're out of the bounds of our chunk. Well, if that's not the case, then of course we just want to return our cells at the local x and local z position. So basically we can just do get cell here and pass that. Of course, what we also need to do is put that function in here. Well, we defined it in the h, in the header, so that's great. What's your problem? That's the old problem. So let's just do get chunk size here. And then we can copy that for the two below here. And then in here, let's say get cell. Yeah, extreme, that's just the way it is for me. It's, well, at least for C++. Did a lot of other languages for my job, but I also tend to code in my free time a lot. And, well, it's just fun. And then you say you don't have a member is solid at, well, just need is solid here, of course. So that should be fine. And, well, for C++, I don't really have a good written down tutorial that I know about. Where did I actually start with C++? I don't even quite remember. Okay, now we have only one error, and that's mpy. Do we need to use a namespace or anything for math, for CMath? Let's just ask our friend. Perfect example. We have our view chat. Why is mpy from CMath not available? So basically, to sum it up, the best way to learn heavily depends on what type of learner you are and all of that kind of stuff. Okay, mpy is a common constant for pi, but it is not part of the C++ standard, while some compilers like GCC, which we actually use, define mpy in CMath or math.h. Others, notably MSVC on Windows, do not. So we could, of course, just define it ourselves, but let's just check whether we can't use math.h. and whether that's then gonna be sorted. If it doesn't, we can of course just include this in our code here. Okay, show me the errors, please. Okay, still that type of problem. And what's this here in World CPP 157? We got this opening. We got this opening. Nope, this is the function. This is the first for loop. This is the second for loop. And this is the if statement. So that should be fine. Did we miss anything there though? Well, basically, if we can actually say that it's false up here, then any other way, if we come here, then we want to return true, of course. Totally forgot about that. And then probably empire is still gonna be an issue though. Definitely is. So let's just define it as we were told by our chat here. So let's just go up here. And that basically defines a constant for us called empire. And then that should, in theory, get compiled now and built. And then we can finally see whether all of this implementation worked. Nope, probably not yet, because we didn't instantiate a player, neither added a way to switch from our player to our standard debug camera that we're using, or back. So basically, it's, well, the implementation, we can't tell whether the implementation is working, but it's definitely not causing any, well, general bugs with compilation. So that's already great. Next up, we should go to maybe our input manager, I think. And then say, if we ever pressed our glfw get key, then of course we need to set that up. And well, I don't really want the escape key here. Interesting. glfw. I think it's just space. Oh, it's key space, I guess. Yeah, and if that's pressed and, well, then we want to basically jump. But yeah, we should push that to process keyboard. That's a good idea. Only have a Y value present here, and then do false for the sprint and delta time to be included as well. So that should already work. But basically we only want this to happen if we are in our player camera. We don't want to be able to jump with our standard debug camera. So let's say we want to do player dot process keyboard, but in player we already implemented our jump function, or did we? I think so. Then we can just use that jump function. Of course, in order to use that, we definitely need to have a well, basically our player, we need to know about our player here, and that's going to be instantiated in our main and in our application. So where do we start our world? Here we have our standard camera setup. So let's just go here. Nope. Here, and then let's say we have first of all a use player camera, and we're just going to start with false, and we have and we have our player itself. And we're just gonna instantiate that at some random position. Probably not at 30, but let's just go with, let's go with 30. So we're definitely above our terrain. That would be nice. And then let's start at maybe 10, 10, because currently our world starts at 0, 0 and only goes further out in the X and Z direction, in the positive X and Z direction, not in the negative X and Z direction. So basically that's a good setup here. Of course, we need to include our player. Include player.h, great. And then I think we also, or did we already add that to our tasks? Yes, we have our player there. Great. So we can basically go back to world application, I mean. And in here then we have our player. Great. And then in the input handling, so in our input manager, we should probably also pass our, well, we could just do a player input manager player, and then what's going on here? Well, the input manager H probably defines this camera. Then let's also define the player in that way. And then of course we need to include the player as well. So then inside here, we're able to set that to be a null pointer at first. And then where we instantiate the input manager, I guess we're just gonna pass the player to our input manager. So let's first of all, before we do anything here, basically, we should check whether our if key pressed, and then let's not do escape. Well, we could do that. If key pressed glfw key escape. Why is that undefined? Well, we probably need to include some other stuff then. Nope, not key press. glfw get key, and then in here we are just gonna do, as always, the glfw get current context with that, and then we can do the glfw key escape, and if the escape key is pressed, then let's just say our window should close. Then we can copy all of that and say if instead our, well, let's just use a random key here, glfw key. Why not go for P as player? If that's pressed, then we want to basically switch between use player camera, or we want to use the opposite of what we currently have as in the use player camera. So we start off with a negative use player camera. We should probably move that bool here. Where did we put that? I think we put that in world as well, right? Or in application. Yeah, let's instead move that to input manager. And then we can actually use it in here. Perfect. So this way we can switch from using the player camera to using the debug camera and back and forth. Hello, Xabi. Sorry if I pronounced that wrong. Nice that it got promoted to you or recommended. Thanks for watching. Great to have you around. And then we already did the jump here. I think that we need to check whether we have the camera here actually. And we definitely check whether the player is on the ground in our jump function, right? So we check if on ground, then we change our velocity in the y-axis and change our on ground variable to be false, basically. So let's head on back to Input Manager. So we got our jump functionality, we got our, we need the move functionality basically. So we have already our Z, X and Y positions. We already have the Y position in here for the camera. What do we do with that then? Then let's say if we put all of the player stuff in one if statement. So if we have our use player camera to be true and we have a player, nope, we definitely have a player. And then we want our, nope. First of all, close that off. And then let's calculate the input. Basically, we have a GLM vec3 move direction. That's going to be our X, Y, and Z. And then with that, we can just say player move in the move direction, get our delta time inside here, and then, well, we definitely need some way of calling our world. Don't we have a world in here? Nope. Do we have a reference to our world in camera? I don't think so, but we should definitely have a reference in our player. Or if we don't, we should add one. So let's say in our player, we have our world. And let's start with a null pointer. What's wrong here? Fix that for me, please. Okay. Don't see what it changed. I don't mind. So we got our world here, and where we initialize. But we pass the world in our update function and in our move function. So if we have the world assigned in here, we can also just cut out these then, I think. So then we don't have to pass them. And in here we can cut them out too. And then, of course, why can't you access that? Can't we just do this then? Yeah. Because it's, well, it's basically just a pointer, right? Okay, so that's fixed. What were we up to right now? Let's check again in our input manager. That's where we were at. And we don't need the world in here anymore. And we can just move the player around. And then, well, basically, we could also just check in here whether, so let's say, do we want to divide all of that? Yeah, I think so. Let's say if we have the debug camera, so basically if use player camera is false, then we want to do all of this. Move all of that to the right place. Hello, Ali Kashif, if that's pronounced correctly. Sorry if not. I have C++ final in my university. I got across your stream by chance. I like that you explain what you do. Good luck with the game. Thanks a lot for the good luck. And well, good luck with your final. And thanks for hanging around. I'm not the C++ expert though, so hopefully you also had some good input in your university. So basically what we're doing here is checking if we use the debug camera. Basically, if we don't use the player camera, of course, we want to use that. And if we're using the debug camera, well, basically then we do everything as we did before. But we need to call the, well, camera dot, wait a second. Then we also need to call the camera dot process keyboard. Right. If we just use our player camera, then everything's different. We want to basically get our move direction, our X, Y, and Z. That's going to be empty though, because it's not going to be getting what happened here. So let's do everything the same as we did here. Then just add that in there. And in the end, we want to player update with the delta time. And what we are missing now is to set the camera position to be our player position. Probably we should add the height of the player, but we can check on that later on. So what do we want here? So our Z should be fine. Our X should be fine. So basically W moves us in the positive direction of our Z. S going backwards. X is gonna be backwards with A, so going to the left, that's fine. And then with a D we go to the right. With a space we go up. Let's just put a 1 in here and a 1 in here. And then let's just, or basically, nope, let's not do it this way. If we don't have a way to use shift for now. But if we want to jump, then let's just call player jump. And then that should be in theory fine. So let's just get that going and see whether it's working or not. So a very basic version of collision detection here. We definitely need to get rid of all of these print statements so it doesn't take ages to load. Okay, so basically right now we're kind of somewhere here. And then as soon as we press P, well, we got a segmentation fault. Great. Let's check that though. First of all, let's basically check our console. It doesn't say anything here. And well, in our debug, of course, same here. It shouldn't say anything here. So, well, let's think about that for a little second. Basically what happened is we got into our input manager and we pressed P, right? And then use player camera was set to true. So let's just add some debug statements there. And as I said, let's remove, what was that called? Generating mesh for chunk. That should be in chunk, or yeah, in chunk, I think. Generating mesh for chunk. Okay. Do we have anything else in here that we want to get rid of? Chunk indices out of bounds. I think that's something that we want to leave in here. So let's try again and just see whether we set the use player camera right. So as soon as that's loaded and we hit P, we're gonna get that segmentation fault, which we had a good few in the last streams of, and still don't quite get these segmentation faults. So let's just once again ask our friend what's going on with those. As soon as I want to switch from debug camera to player camera, we get a segmentation fault. Forgot what's that about again. Okay, so, well, we actually didn't set up our player or our world reference in our player. So basically we should do that as soon as we create our player. So in our world CPP, nope, in our application CPP, here we create the player and we already have the world. So let's say player dot world is equal to world. And then do we need to do anything else? Nope, I don't think so. Should we have set that up as a pointer? It could be fine like this, right? So segmentation fault is always, or my experience so far is always a null pointer referenced. Okay, still the same thing. So then we can, as he told us, make sure you assign world pointer to the player after creating both objects here. Well, then let's do it this way, as he told us. Yeah, but that has to be point, and then world. What's the problem here? Yeah, world is already a pointer. Let's also set player to be a pointer then. Might make more sense. And well, we messed something up here. Player should have been a pointer from the start, I think. But let's just ask our friend, or what's the problem here? Okay, we can't convert from GLM vec3 to... Yeah, okay. Then let's just say... You are a new player with that, and then let's say this is going to be 10, 30, 10. So we start somewhere in our world, and then we can set our world to be, well, the world for our player, and then hopefully it's gonna work now without any segmentation faults. Let's check. Once again, segmentation fault. Then we could do these assertions. Before we use player or world, assert player to be not to be null pointer. Could do that. let's check again. So first of all, in our application, we create our world as a new world. And then we create our new player. And there we could also just pass our world, I think, instead of doing this. And then in our player, let's also add our world. And then let's not do that, but instead do it here. Player world, and then somewhere here should be able to set world to world. What's your issue? Not a non-static member or base class of class player. Am I stupid? Ah, well, I am. So then back in here, that should be fine, and hopefully that's gonna be fine. But as he told us, let's actually check before we use. Yeah, let's just try one more time. World is loaded, P, and we get the segmentation fault again. Okay, so we don't have that position, apparently. Or what? Or maybe, well, basically it gets here and then it tells us that it has an issue here. Before using player or player world, add assertions or checks. Yeah, I would love to know what that's about. Where do I put the assertions then? Probably outside of player, so maybe here. Let's start with that at the top. And then in our update function, we are gonna make sure, oh, well, it's not even in here then, okay. So player, back, we want to include the CAssert. And in our update, we want to check whether we have the world, right? Okay, and then in our move function, we do the same thing. But let's actually do this here too. And then let's try again. Then it should at least tell us what's going on. And then, well, basically we need to fix that. Okay, so we got a problem here right away. What's that? I didn't add a breakpoint there, I thought. And he didn't tell what was going on. Okay, so misclicked or something? I don't know. P and then paused on exception. Yeah, that's fine. Using player camera. Okay, so it's even before that, I guess. Okay, then help me fix that by passing a reference or passing a pointer to world while to player, a pointer of world to our player in the constructor. Let's kill that and see how we can do that. Okay, so player already has that, right? So in our constructor we have world and in here world. Yeah, so that should be totally fine. And then where we create the player in our application, here we create the player somewhere there. Player is going to be a new player with a starting position. That should be fine. And we pass our world. And our new world gets created here. So it should be totally fine. And there shouldn't be any way of world getting 0. But let's just say if we create that player, where's that player? Let's say if world is null pointer, then let's put out an error. But it shouldn't be. Especially as we see the world now, it shouldn't be just a null pointer. Okay, but we didn't get that error. Got the same error again, of course. But that's, well, that's kind of weird. But maybe, do we have world as a public variable here? Yes. Okay, so when the player gets created, this is gonna be a null pointer. Can we just leave that out here? Because of course it's gonna be a null pointer if we do anything enough into this. But I don't think that could update that, because if we put the world, then it should be the world, right? Okay, we got, didn't close it before running again. And we always get those build errors for our H files, for our header files, especially for the enums. I don't know what's that about. Okay. And once again, these bloody damn segmentation faults. Kind of my kryptonite. Okay. So then in application, once again, let's check whether we don't change the world or anything as he told us. We don't really do anything there. But the thing is, basically, we should check where do we update the player? Well, basically from within the input manager. So in there we should check, do we have a reference to the player in input manager? Yeah, that's a null pointer. Do we set that somewhere? Probably not. Probably that's the problem the whole time. So let's do input manager set player to be player. And then we, of course, don't have that functionality yet. So I think we defined that in the header. Set camera. Set player. Player. Play. Okay, so then hopefully we don't get that segmentation fault again. And then we can also get rid of these assertions we put here, right? Where did we put them? In the player update and move, right? Okay, let's check. Yes, now we're the player and we're affected by gravity. We're moving backwards. Okay, so we need to figure that out. And we're moving quite fast, I would say. But we're moving around. Totally in the wrong direction though. Okay, then let's close that and check again. So basically what we do is first of all check input manager, first of all. No? In here we do the process input with the delta time, and if we use the player camera, which we just did, and press our W, then we should go forward. So our Z gets plus or minus with S, and for X we get a minus for A, and with D we get a plus for X. Space is gonna call the jump function, and then we basically have our move functionality here. And then the move, we should also put our sprint in here. Of course, then we'll need to change the whole function as well, but that's not gonna be that much of a problem. Let's start with player move bool sprint, and in player.cpp move bool sprint. Okay, then let's check again. We have our old position and our intended position. Well, we need to check. So basically what we did now is what I described before. Let's just get the world a little smaller so I can build that a little faster. Where is it? World size. Let's just go with, I don't know, 24 for now. Let's save that. Input manager, that should be fine now. And then let's check that again. Because what I wanted to point out here is basically that we're now just moving along the axis. We need to check for the camera's direction in order to calculate a vector in that we travel, just as we do with the other thing. Why though? Okay, pressed it for too long. So if I press W, we just go into the Z direction, basically. That must be, no, it should be, yeah, it should be the Z direction, but of course we need to turn the direction. So the move direction is also dependent on the camera orientation, basically. So let's just have a look at camera process input in order to fix our player move function. So in the process keyboard I meant, so we definitely need to define a forward or front type of direction. And this is just a function of our camera. So actually what we also need to do in our input manager is process the mouse movement, I would say. But we already do that somewhere, right? So I think we do that in the main type of thing. So we can just do player, and then we just need to know about the camera's direction. So maybe we should actually get a reference to the camera inside player or pass it in here. Let's check. Do we already have a reference to the camera? Nope. Then let's just pass that into that function. So move also needs a camera. Camera cam. And in our source file, move what was going on there? Camera, and that of course needs to be that way, right? What's your problem now? Camera cam and camera cam. Ah, well, probably we don't have that included in here. Okay, so that's working, and in here we need to do we need to do the same thing? No, it's fine, perfect. As we included in the header, we don't need to include it here, of course. But in here we then need to get our, well, basically our direction. So let's say our front face, let's say that's a GLM back 3 once again. Forward is cam.front and forward Y is 0. That sounds good. Let's check again in our camera. Where is it? So in our process keyboard, we do basically the same thing, and then we want to normalize that. Let's just do that real quick. Player normalize. And then we also need those other directions, right? So we need a right. And then, well, therefore we're gonna need cam.up, I think. That shouldn't be problematic though. And why is that a problem now? Let's just first of all say cam up. Huh? Okay. Cam up. And then what's going on in camera after that? That's the sprint type of thing. Let's just use that as well. And then the velocity can be calculated this way as well. And then we just do our position like that. So let's say our player, that way we have that out of the way. And then let's say we have, well, we don't have a speed here. Let's actually implement a speed for the, we have the move speed, so let's use that. Move speed times delta time times sprint factor. And then we'll do, well, our, how did we call it in camera? I'd like to stick with something similar. Just position. Yeah, that's gonna be the intended position for player then. So we can check for collisions. Intended position. Well, we don't have that intended position yet. Then let's just do intended, or let's do it as a vec3, and let's call that intended move. And then we could do it as move direction. Nope, that's what we get in there. And how do we do that then? Let's check the camera again. Where do we use the move type of thing then? Don't get a move type of thing there, we get the deltas. Okay, that's also fine. But we can do something similar here. I think similar to this at least. So let's say we just have, so we have these move directions, but we need to put it in the direction of our, well, of where we're looking at. How do we do that? Let's just ask our friend. Help me out real quick. I want to make sure here that we move in the X and Z direction of the camera. I wanted to remove that line before we do that. Okay, so we got all of that, and then we got the move vec. Yeah, I can live with move vec. And that's going to be forward times the move direction. That sounds great. So basically forward times Z, right times X, and all of that times the velocity. And then we have, what else do we have here? Right is normalized. Forward is normalized, just as we did, perfect. And then we have old position, and in the intended position, we do move vec. Let's just copy that, easier. And what's that? Move speed and delta time. We already have through the velocity, where we multiply move speed by delta time and the sprint factor. So that should be fine. And then after that, we only have our helper functions, right? So in theory, at least, that should be working now. I just noticed someone of you probably that is maybe even still watching is the 600th subscriber. Thanks a lot to all of you. Where is our debug? There. Okay. Well, the build didn't even finish. Okay, what's going on here? So input manager in static function, static void process input, no matching function for call to player move. Because, well, in input manager 65, we didn't add the sprint. Yes, we did. Because we need the camera. So let's just say camera. Yeah? Okay, so that's once again something really annoying in my eyes. It keeps the error from the debug build, and then we change this and it's still underlining that because it's still thinking the issues there. I don't know. Okay, so maybe that's all, but yeah, I think so. That should be all. Okay, so we can still move around with our debug camera. Let's try with our player. Okay, now I can go through the world. That's great. And we don't, well, we can see into the walls a tiny little bit, especially if we move around fast. And we have an issue with going up. I don't want the player to be able to just run against a hill and just get teleported up all the time. So instead I want you to be able to jump up a hill, but I think we also need a much higher jumping force for that. So let's first of all, before we do anything, go to player. Nope, not that player. This player, probably this one. We don't have a jumping speed currently, or jumping force it should be probably. Here we have jump. Let's say this is 10 then. Probably that's too much, but let's just check. And then we need to change basically what I just said about the, well, basically that's an auto step function like you have in some games. I don't really like that too much. Okay, that's a little much, so maybe we go somewhere in the middle, 7, something like that. That should be then better, I think. And then let's ask our friend, how can we stop the player from running up hills automatically? It should need the use of jumping. Okay, so yeah, that's what I thought. Let's define that in, probably in player header. Doesn't really need to be constant, I think. But then let's check. Where do we do that? Probably where is that? Don't do anything with the y-axis here. So we probably need to add that too. So in here we currently do the, well, here we have the const max step height in there, that's fine. But then we need to check whether we, well, first of all, we need to get our current ground and the intended ground, basically the heights. So let's just put that here. And then let's check if the difference is less than max step height. And if it is, we'll return. Yeah, let's see. I would actually prefer, because if we return here, okay, so if the position is free, then our position is gonna be that. What do we do here? What did he change here? Yeah, let's just try that. And then we don't even need this here, right? As far as I'm concerned. Okay, let's go to player, and then we don't walk up the hills, but of course we can jump, but we can't jump up to another platform, right? Okay. So now I can't jump to a higher level or ground. I think we messed up. So basically, yeah, he agrees we always block the movement to higher ground if the height difference exceeds max step height, even if the player is jumping. Okay, so basically everything's the same, I think, except we want to check whether we can step up. But we shouldn't then step up too much, right? Ah, well, we check the intended grounds instead, yeah. So that should be fine. And then instead of doing that here, we're just gonna copy that and go through it then afterwards. Let's actually copy all. So what's your matter? Ah, well, did we forget to put a semicolon there? Okay, so if our can step is true, and that's going to be true if our intended ground minus our current ground, so the difference between of them is smaller than our max step height, which is currently half, then that's going to be, well, basically false if it's higher than 0.5. Did he change the max step height? I don't think so. It didn't even put it in here. Okay. So if that different is, probably you shouldn't check current ground though, right? We should check our current height or current position of the player, I would say. But let's go through this code that he proposed here. First of all, we check whether that's true. If that's true, we check whether the position is free by the intended position or radius of our player and the height. And then with that intent, we push that intended position to our player position and return. Then down here, first of all, we create a position that is, well, basically only our X movement that we did, not the Y and Z movement, as we pass the old position for Y and Z in here. Then we also have our X ground. The X ground is gonna be our height at our X position and our Y position, our Z position, sorry. Where do we define that? Well, we just define that there. So if that's fine, well, basically we then check again whether we can step, and that's gonna be that's gonna be checked by whether we're on the ground or not. Sorry, whether we're on the ground. If we're not on the ground, then we're allowed to step, or if we're basically not wanting to step more than step height, and that's fine, and then that's true, and we're gonna change our X position, same for the Z position. Thing is now, what about if we're not on the ground, but at 0.5 height? So let's ask our Copilot friend. So to my understanding of the code you proposed, we can even step up if we're falling and are less than we and aren't higher in the air than our intended intended cell positions height. Weirdly formulated, but maybe he's gonna get it and help fix that. So yes, your understanding is correct with the current logic. If the player is not on the ground, they can move to higher cells regardless of the height difference. This allows the player to climb up steep slopes or ledges while falling, which is not realistic. So how to fix it? You should only allow stepping up if the height difference is within max step height, walking up a slope, or the player is moving up, jumping, not just falling. But we also want to change that basically, so it's not moving up or falling. We want to change it so that the player needs to be jumping high enough. If the player is in the air and their feet are above the intended ground, they are jumping up to the ledge. So improved logic is going to be this. Let's check that in the code. Let's just copy this whole thing. And then I think we can replace the stepping if can step, right? Yeah, should be fine. So stepping is going to be intended ground minus current ground below max step height. Well, basically that's never gonna happen except if we want to later on provide a setting where we can, well, basically allow the player to auto step one block. That could be a thing. So if we're on the ground and the max step height isn't overshooted, then stepping is going to be true, and jumping up is only going to be true if we're not on the ground and our Y position minus height times 0.5 is higher than the intended ground. And then if stepping or jumping, we can do the check for if the position is free, and then we can actually push our intended position to our position X, and well, same for Z. And then, well, let's just ask him to do that for me, please. So hopefully he gets that I meant the repeat similar logic for X pos and Z pos, because it's just repetitive. Okay, so then let's just copy that and hope for the best. No, let's just go through that. So as before, we create our X position from our intended position X, so the future position with our movement already calculated in, and old position for Y and Z. Then we have our X ground for this new X position. Then we can check our X stepping as well as our X jumping up. And if either of those are true, then we can basically move our X position there. So let's just make that clear by check if we can move in this direction. And then this is only gonna be check whether we can move in X direction. And this is check whether we can move in the Z direction. So basically down here it's the very same thing, except of course that we don't use the intended position, so a future position for our X and Y, but only for our Z instead. Then we once again calculate a Z ground, a Z stepping, and a Z jumping up, basically all the same as we did for X. And then if either of those are true, we want to check whether the position is free, of course, once again, and then we can just go ahead and move there in the Z direction. So let's hope that now our player movement and very basic physics are to our liking. Okay, we're in the game. Let's hit P for entering the player mode. We can still clip through these borders, so I think we just need to increase our radius of our player maybe. We can't move up here, but if we jump we can move up. Great. But if, let's say, for example, I wanted to jump and then move after I've been going in that direction, falling down too long, then I can't move up. So if we're here on this base layer, then we can't move there, but as soon as we jump, we still can't move there. Only if we're still high enough, and we'll get stuck behind that if we aren't high enough. Okay, so then we need to fix that clipping. So it basically happens, when does it happen? If we walk into a straight wall, it doesn't happen. If we walk into that corner, it doesn't happen. When did it happen? Don't really get why it's happening sometimes. It's definitely happening now in that, well, probably it's the, well, can't really check now. Let's say we have some clipping here. Can we just fix that by increasing our radius? Let's say we go with that 0.5 he proposed, and then we also need to implement the height to the player height to our player camera position basically. Okay, let's hit P, and then, well, we can still clip through these blocks, but we cannot do that in all the directions. Ah, yes, we can, but I can't do it on a flat wall here. I can do it on a flat wall here. Nope. It's only when I go to the side then. We shouldn't be able to get that far over here though. Okay, so let's check that in a second. First of all, I want the camera, or basically the player sets the camera after moving, right? Nope. So then we did that in the input manager for use player camera. We want the camera position to be the player position. But let's then say we calculate a new player position. and then it does exactly what we want. It adds the player height to our thing. Don't want that to be half actually, but let's just check whether that might even be correct. And then let's already get that prompt set up. Well, we actually changed the radius. Maybe that's even already the thing. There we go. P. Hello? Okay, so we're higher up and that way we can't clip. Ah, yes, we can still clip. How did I just do that? Can't recreate that. And then we also need to reduce the player movement speed, I would say. Player. Okay, so our velocity sprint should only be 2 times the speed, I would say. And in our player.h, let's say we only move by 2. And then we can move by 4 if we're sprinting. Okay, much slower. That's great. Yeah, the jumping force is still too high. I would like to only be able to jump up, I don't know, 1.5 blocks or something like that, and not 2 at once. Like we can we actually do 3? That was 1, 2. But if we were to sprint, we might even be able to do 3. Nope, okay. Anyways, let's make sure that our player, and then we have the jumping. Where did we set the jumping force again? Well, it's not included in the move direction. It's in the jump function here, up here, of course. Let's say we only had 5 as we had in the beginning, because I don't think well, as when I thought that that was an issue, it was another issue. I think it was with the, well, basically with the collision detection logic. So probably now we can jump up by 1 block. And we can't, or I can't clip through anything yet. What if there is a too high wall though? Can we, yeah, then we can clip through stuff. And that's not great. Okay, let's talk to our friend about that. Maybe we should just increase our radius. Check only tests if the player's bounding capsured cylinder collides at the intended position, but does not account for the fact that the player might be able to step up a small ledge but not a tall one. If the wall is 2 blocks high, your current logic allows the player to move as long as their feet are above the ground at the new position when jumping, or the step is small enough when walking. The problem when jumping, you're checking bool jumping up is equal to not on the ground and position y minus height times 0.5 is higher than intended ground. How to fix? Okay, jumping up on the ground and the condition that we had before and less than the max jump height. I don't think that that really is the issue. I don't think he got what I meant with clipping. But let's check. Let's basically do this and then this. And then let's define that in player. And then we also need to do that for X jumping and Z jumping. So basically copy that. Okay, and then same goes for here, right? Okay, let's check that again. That's not really what I meant though. Do we need to increase the player radius or move the camera back a bit? That could also just be enough if we move the camera a little further back. Okay, if the camera is inside or too close to the wall, blah, 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 blah. Okay, so as I said, increase the player collider radius. Okay, or move the camera slightly behind the player's position. Okay, and for a first-person camera, it recommends that we offset it back by at least the player's radius. Okay, so then we just subtract minus player radius. That's great. And we don't want to use this version, well, because we don't want to do third person, because we then would have to have a player model now, and we don't have that yet. Maybe later on there is going to be also support for third person if you prefer that, but for now I'm not planning that, as we're later going to add another form of third person camera, but I don't want to spoil that. So when setting camera position, that's in, where do we do that again? In up update. Nope, it's in the input manager. And there at the bottom we do that. And there we do all of that. And then we just need to subtract that at the end. Nope, 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 nope. Okay. Okay. Only problem now is we don't have the front. That should be easy. And then, don't we have a player here? I think we have a player here, so it should be just like that. And then hopefully we don't get any clipping anymore. That would be great. Okay, world is there, player is there. And if we, is there a too high wall here? Don't see any yet. Let's walk over to these brown boxes. Still an issue. Then let's move it back further. Then let's say, or we could just increase the player radius, of course, now. But I think I would like to just do that by 1.5. Maybe. Let's check whether that's viable or whether that's too much. And one more thing that I would like to change as well is probably that we can actually switch from our debug camera to our player and have the player to be in the position where our debug camera is. Yeah, so it looks as if it's working. I can't go higher up than I was before, right? Ah, that's a weird thing now. Nope, that's not working nicely. I think we want to remove that again. Weird that that double semicolon wasn't an issue, but well, basically it's not doing anything then, so it should be fine. So let's go to player H and let's just say we had a radius of point. A tiny increase could already be enough. Let's check with 0.6. Okay, weird. Can still do that. Something's off here. Let's have a look again. What are we exactly subtracting in the camera? Something's off with our subtraction logic, I think. That was in input manager, sorry. So basically, we subtract our camera front by our player radius. Why isn't that working though? basically the clipping now probably only happens, let's check that again, it only happens if we move somewhere and then turn around with our camera, because then the camera can move into the block. Because it shouldn't be able to move into the block by going straight at it. We can also hold space in order to jump. Should think about whether that's the way we want to do it. Okay, so I can't move. Well, what's going on here? I think I want to do that in a different fashion. Okay, let's say, can't we create some AABBs in order to then do real collision detection? But that's gonna involve getting rid of quite a lot of stuff, but it's gonna be worth it, I think. For all the terrain, and then check the AABBs of only the cells around us. Stop that. We only want that to do. We only want to do that for the vertical faces of the cells. So can we implement real collision detection with AABBs that we add for all the terrain, and then check the AABBs for only of only the cells around us? Let's stick with everything we have for our Y values and only do that for X and Z. Okay, yeah, that's easy to do that. I think we're just gonna do that in the cells, right? Yeah, that sounds good. So let's first of all get the struct, go to our, yeah, let's go to our cell and do that there. Okay, and then cell AABB is gonna be, where do we set that in the constructor? Let's say we have our, should we do that for our local? Or for our world position? I think world position might make more sense, right? But we don't have our world position in here. So let's undo that real quick. Where to put all of that? Cell or chunk, basically. Okay, that's a good idea to put the AABBs in a header, I think. Let's add that here. AABB.h, put that in there. Probably we should include GLM then. Pragma ones would be good as well. And then where's our tasks? We're gonna need our AABB to be compiled as well. And then for the terrain cell, for a single block, min-max corners for a block at XYZ is trivial and can be done on the fly. If your cell class represents a single block and knows its world position, you can add a method like get ABB for the height. That's a cool idea. No, P doesn't understand how our cells are set up right now, but that's fine. Let's just do that then. Or let's just do the AABB for a cell for all the side vertices at once. Of course, that's not gonna be ideal if we ever wanted to have caves or anything like that, but I'm not too keen on going into caves right now. Let's go to cell though, and we could always change that anyway, so no need to worry. Include AABB.h, and then well, it wanted us to do that in the cell header. Okay, then we have that, and we're just gonna add our getABB function. And then in the cell.cpp, we can add that function. But we'll need to think that through once again. So cell doesn't have a reference to chunk. Thought so. Ah, no, we always pass that as a reference. So let's do that here as well. And then once again in here. Okay, and then why are you mad about that? Should be right. I don't care. Ah, no, because we have the AND operator there. Sorry. Okay, so we have those. And then that's basically going to be the world position. The min y is just going to be the y. And the max y is going to be y plus cell size. Yeah, that's not correct, right? Because min and max y aren't correct. Don't we need to get min y and max y dependent on the neighbor cell as well? Could we maybe I don't wanna say anything that biases its output now. Okay. Yeah. Great. How to do it then? Neighbor top and cell top. Yeah, that makes sense. But of course, we first need to get those. That should be easy. What for do we need? Ah, well, we need neighbor. Then we could do neighbor. How do we define the direction? Okay, help me out again. Well, basically we need to do it for all the directions, right? So we should do... Hey Qua, nice to have you around again. Not yet. Can you though? Damn. Should we worry about that though? Should we do it this way instead of the way we're doing it right now? I mean, it's gonna be fine for very basic stuff. Or we could add AABBs for every side face that we draw. That would be super easy because then we could just take the data from our, well, add quad draw method. Basically, it's these 4 positions that we would need then. So we could even add those AABBs in here. But that's also calculated on the fly. You can do 1. Okay. Oh, okay. Oh, damn. Then please don't do it. I would miss you. Let's say we wanted to do it. We could have done it with the info that we have in draw side, basically. We need those 2 things. And that means we have those 2 things, but that means we also need to pass the direction that we want to have the AABBs for in here, basically. And then we don't need a float y, we only need that direction then. So let's go back to cell here and replace that here as well. And then neighbor is of course going to be a cell reference, and that's going to be neighbor static cast in direction. Perfect. And then neighbor top is going to be, if we have a neighbor, it's going to be get height, and if not, it's just going to be 0. So we also can't walk into our world if we're, well, outside of the world and drop to the very bottom that we defined, so basically 0. And then, well, we have min y is going to be the neighbor top and max y is going to be the cell top. Right, yeah. But then we would also, we'll also need to somehow get the, no, the AABB is actually x minus z minus, so it's a cube. Not a cube, but whatever that's called in English. I don't know. Doesn't matter. But we also need to calculate the half size, which I just removed. Shouldn't be too much of an issue. We had that somewhere here. Just copy that. So then it should be fine, right? But we, of course, will need to use that somewhere. So, and we'll need to basically check all the directions, right? So we should maybe get a vector of AABBs. So get AABBs as a function would also be nice, I think. We implement that, well, not like that, but we could implement it then in our movement function basically once again. Let's first of all try whether we still get a valid build. And then probably we'll just leave it here soon, as I'm kind of getting tired a little bit, unfortunately. So if we hit P, and then we should definitely work with key down and not with key pressed or whatever. I don't know whether there's this distinction in there as well. But basically now that's still our old collision from before. And if we once again move over to here, we can still, as we have the two high blocks, we can still easily clip through the wall. And that's kind of awkward. How could we use our old method and implement that? I think we could also just, if we were too close to the wall and then moved around, we could just move our player further from the wall, but that would be kind of cheaty, I would say. And maybe, just maybe, this setting back the player camera is actually the thing here. Because when the player camera is at the center of our player, that shouldn't happen, right? Let's just leave the AABBs here for just a tiny second. Go back to camera. And then here in... No, it's in input manager, sorry. In here, let's just comment that out for a second again. Okay, we definitely need that feature to move with the debug camera and then switch to the player camera. That's kind of annoying. Yeah, when we do weird stuff like this here, then we can definitely still clip into that. And let's just try and increase the radius real quick. That should be a cheap and easy solution compared to calculating all the AABBs and so on. Qua, tell me, are you still around? Is there a way to abort building in here? So if I hit start debugging and then want to abort that, is there a way to do that? Okay, still clipping. But only sideway movement now makes the clipping. Also jumping, okay. But if we walk to it, it's working. Yeah, but I think then I'm just gonna set up the AABBs before the next stream and show you what I came up with then. Because I'm, well, as I said, quite tired now and yeah, don't want to waste my and your time here any longer today. So probably gonna be live sometime in the next days and then show how I fixed that. So then we can actually start with the model loading in the next stream and just show how I fixed that and start the model loading, so we can actually add some trees and other plants and so on to the world, which is gonna be a huge improvement to this very boring, very bad textured area here. So as always, I really hope that you enjoyed watching, and if you did, then please leave a like, comment, and of course subscribe if you haven't already. And then, well, have a great evening and see you next time. Bye bye.